Okay, this is Dr. C, and we're going to be talking today about test-driven development with NetBeans and JUnit. So let's begin by talking about JUnit in general. JUnit is a testing framework to test your software, written by Eric Gamma and Kent Beck, and used by developers to implement unit testing. So what JUnit is going to provide for you is a way to accelerate your whole programming effort, increase the quality of your code, and reduce the amount of time spent debugging. So what do we focus on testing here? Well, it's part of the concept of test-driven development. Writing tests can only improve your code, and the tests you write, once they're in existence, can be used over and over again as the software is developed. You can prove to people that your software works even after you make changes, which is typically where software breaks. It will also improve your confidence in your software, the quality, and you'll get more sleep because you won't have to be spending all-nighters debugging your code. And you're really going to get to write code sooner by writing these tests. So what is JUnit? It's a Java library. It's Java code. There are two versions floating around out there. The one you want to look at is the 4-point whatever, 1, 2, 3, 4. There's a 3-point that came earlier than that, but 4 is by far more advantageous for your testing needs. It's got tools built in where you do your test by making assertions about what should be true about your code. Then you run the tests, and JUnit automatically reports the results. So the basic philosophy is let the developers write their tests, and it's going to be easy and painless. So the question is often asked, well, what do I test when I write my code? Well, when you're writing code with functions that basically do one thing, what you want to do is write tests that could break your code. So you want to imagine where programmers make mistakes, and that's what you want to test. So does my function work with 0 inputs? Does it handle the empty string? If I try maximum values, does my program still work? Does my code still work? Negative numbers. These are often the places where your code will break. Okay, so let's jump in and see how we can use NetBeans to do our automated testing with JUnit. So I've got here NetBeans open, and what I'm going to do is I'm going to start right from the beginning. I'm going to create a new project, and I'm going to create a Java project. It's going to be a Java application, and hit next here. I'm going to call it, let's call it my Java. Just name the project. So now we have, if you look over on the left side here, we have my Java is the name of the project, and we have source packages. We want to click on source packages because that's where we're going to put our source code. And by default, we get a default package. So in Java, everything has to be in a package, but if you don't explicitly put it in a package, it goes into the default package. So I'm going to create a class in the default package. So I'm going to right-click on default package, new Java class, and I want to name my class vehicle. So I'm going to make V-H-I-C-L-E, vehicle. Notice down here, warning, it's highly recommended you don't place Java classes in the default package. That's often the case, but for our purposes here, we're just going to keep things simple, and we're going to leave things in the default package. It doesn't really hurt anything. So I'm going to finish, and now I have the basic structure of my vehicle class. Now I've got some comments here. I'm going to just erase those, take those out. We can leave the author in. And so we're going to have a class called vehicle. What is my vehicle class going to look like? This is going to be for a vehicle simulation. Keeping it very simple, I'm going to create 2 instance variables for my vehicle class. And then I'm going to public vehicle. I'm going to make a constructor int x and y, and I'm going to set my internal variables this x and this y equal to the parameters. So now I have a constructor. I'm going to set my x and y positions for the vehicle. Now I'm going to write several methods. I'm going to actually write 3 methods for the purpose of illustration mainly. The first method I'm going to write is something called isVehicle in Neg World. So I'm going to imagine a game board of some kind, and if the vehicle ends up having either a negative x or negative y value, I want to be able to have the isVehicle in negative world return true. But we're not going to be really writing code here. We're just writing the skeleton of our class. So this is the way we do test-driven development. We write a skeleton that really doesn't do much, and then we write a test to test it, and then we start writing the code. So the problem I'm running into, I'm getting a compile error here, right here. It says missing return statement. So this is a Boolean, it's expecting a return. So let's just keep the compiler happy and return true. So we're not really implementing any logic here. Next method I want to write is I want to be able to move the vehicle by some x, y coordinates. So I'm going to call this method move by, and I'm going to have an int x and an int y. And since the method doesn't return a value, the compiler is happy, and I don't need to make any more changes. And now I'm going to implement, I'm going to move this up here so you can see. I'm going to create a method called, return a double, called the distance. So I want to be able to determine the distance between my vehicle and some point x, y in this universe. And again, since it returns double, I've got to return something. So let me return 0.0. And now I've got my function. I've got all my functions, got all my methods. This looks like it's going to work. You can see we don't have any red, so we should be able to come over here and say compile file, and output is OK. So the file compiles. So now we're done with step 1 of our test-driven development. We have created a skeleton class that really doesn't do much, doesn't really have the functionality, but it's got the functions that we have written here. So we've got our code, our basic Java code. Now, this is where the magic and beauty of NetBeans comes in. I'm going to come up here to the Tools menu, and under Tools menu is Create Tests. So I'm going to press Create Tests, and it says, OK, the class to test is Vehicle, because we were inside the Vehicle class when I selected Create Tests. It's going to create a class for me called Vehicle Test. And the framework is going to be JUnit. We're going to look over here. There's some other possibilities, TestNG, but we're going to use JUnit. And these are just leave everything checked, and I'm going to hit OK. And now it's going to give me a choice. Do I want to use JUnit 3 or 4? We're going to use JUnit 4. So I'm going to select that. And magically, I now have a test program called Vehicle Test. So the code, the skeleton code, has been generated for me. I'm going to take some of this stuff out, knock it out. It's got all the imports that I need from the JUnit library, which is included in NetBeans. So when we look at this source code for the test, we see a fair amount of code has been generated for us. So let me step you through this. The class that's created is Vehicle Test, automatically named for us. It's got a constructor. We don't need to do anything with that. And what you're going to see at the beginning here is a couple of methods, before class, after class, before and after. And these are done with Java annotations. So this little ampersand here has very special meaning for Java. And Java does things behind the scenes when it sees one of these Java annotations. We're not going to use these 4 methods, but I'll briefly explain to you what they're there for. Before class is where you want to put any code that will execute before you do any tests at all. So anytime you want to do something before your tests, you would put it in this method here. Teardown class is going to happen after all the tests are done. So maybe you're reading and writing from some locations or doing something. The @before code in setup, this code will be executed before every test is executed. So this maybe you want to load in some objects from somewhere, but for our purposes we're not going to mess with these at all. So we come down here, and this is the heart of the testing. So every function I had in my vehicle code has a corresponding function here. So remember, we had a function called isVehicle in Neg World. Well, there's a function here called test isVehicle in Neg World. And right above, right preceding that function definition is an annotation @test. So basically, the testing framework looks for methods that have this @test annotation, and if it has it, it will run it as a test. Okay, so we have one for test isVehicle in Neg World. We have test move by that's been generated for us, and test distance. Okay. Now let's delve into what a Java JUnit test looks like and what's being done for us here. In this first test, we see here on line 38 simply something that gets printed to system out. So it sort of announces to us we're running this test, we're in this method isVehicle in Neg World. Then we have an opportunity to create an instance of our class. It doesn't know what constructor we might want to use, so it by default sets the instance to null. And the way this testing works is you make assertions. So these functions that we're going to see that have the word assert in them is part of the JUnit framework. So assert equals says, I want to assert that these two values are equal. Now, where do these values come from? Well, expected result is what you're going to expect when you make your function call, and the result is what's going to be generated when you make your function call. So notice that we're calling isVehicle in Neg World on the instance, but the instance is null. That's fine right now. So this is how your code is going to check to make sure things are working properly. Now, the way JUnit's default system works is they introduce this little code here, a little comment. It says, to do, review the generated test code and remove the default code to fail. This is a JUnit function called fail. Whenever you call fail inside one of your test methods, the test will fail. So these tests are guaranteed to all fail, which is fine. So this will compile. So all your code has this. Your job is to take this out and then make the changes so you can actually test your code. So they all fail. So let's run this. Let's run this program. I'm going to run your test program. Run file. That's all you have to do. And now, I can move this up here so you can see the output of the program. Really nice. There's a nice little visual output. Red means failure. Okay. And so no test passed. 3 tests caused an error. Okay. So what's happening? You can look at the error. We're getting null pointer exceptions in the code. Why? Because, go back up here, the instance is null. So we're calling isVehicle in Neg World on a null reference, and that's going to throw an exception. So this now is an important distinction in testing. Your tests can either cause errors or they can fail. When a test causes when an error is reported here and here and here, that means that the code, when it was executing, threw an exception and we couldn't even test in any way values. So you don't want to have errors in your code. What you want to have are failures, and then we're going to correct the failures. So the steps, by default, you're going to get the whole test is going to fail because of errors. Then you want to get rid of the errors and get failures. Then when you get failures, you want to go back to the code, correct the code to get rid of the failures, and then you're in good shape. Okay? And you can see over here in the right panel is this, what gets printed in system out. So anything you print in system out is going to show up in this little window over here. All right, so let's take a crack at removing some of these errors and turning them into real tests. So let's take test this vehicle in Neg World. First thing we want to do is turn the instance into, actually create a new instance. So let's create an instance at 1010. Okay. We expect false is vehicle in Neg World. None of these values are negative, so it's not in Neg World, so we expect false. So now we make the call and we assert that the expected result should be the same as the regular result. Now despite that, we've got to get rid of this code because we don't want this thing to automatically fail. So I'm just going to save that and we'll run the code and see what happens. Now, no tests. So the whole vehicle test failed, but we have two errors and we have a failure, which is good. And we get failed, expected false, but was true. Okay, now why are we failing this test? Well, go back to the vehicle. This always returns true no matter what. Okay, so now our job is to fix this code. So let's take a shot at determining whether we're going to be in negative world. So when are we in negative world? If the x value is less than 0 or the y value is less than 0. So we can say this x less than 0 or this y less than 0. So we're simply going to return this Boolean expression. Easier than writing if statements. And now we go back to our vehicle test and let's run our vehicle test. And bingo, we are now in a third green. So this is the exciting part about testing. You go from red to green. All right, so let's move down to our next function. We want to move by a certain value. Now, I gave you this because this function doesn't return a value. So we're going to have to do a little work to actually check it. Here's our instance is null. I'm just going to copy this over here. So we have a new vehicle. We're going to move by, let's pick some number. Let's move it 1 and 1. Okay. So now you've got to ask yourself, what can you assert? Well, I'm going to take assert equals, okay, and I'm expecting the new x value to be 11. I can just type 11 in there. And then I can say instance dot x. So I'm asserting that the new x value should be 11, and actually same for the y. So I can just copy that. So I have my two assertions. Notice I have two errors here. Hopefully this will turn into not an error but a failure. So let's run, because we haven't changed the code. And now I have test move by failed and has the yellow indicator, and it said expected 11 but was 10. So now we go back and we have some fun. We go into move by, and this x plus equals x, this y plus equals y, and go back to our vehicle test. Going to run our test file again, and now we're 2/3 green. So we're really in good shape here. Now let's go to the third method, test the distance between our vehicle's position and some other vehicle position. So let's choose x is 13 and y is 14. And I think I copied this in here. Yep, nope, I didn't. I wanted to copy the vehicle constructor. So now I've created a vehicle at 1010. What is our now? This function returns a double. So this gets us into issues with respect to computers and floating point numbers. And very often when you compare two floating point numbers, they're going to be off by a tiny fraction. So you have to really be careful about this. But our expected value is going to be 5, because we're making actually a 3, 4, 5 right triangle. The result is going to be the distance, okay? And I'm going to assert that my expected result equals the actual result, and there's a third parameter here when you are comparing floating point numbers in this case, where you can put, I'm going to say I want this to be accurate within 1/100th of a position. So this should take care of any floating point issues we might have. So here we have assert equals. We've gotten rid of the failure case. I'm going to run this. You can probably expect what's going to happen, but we have 2 tests passed, 1 test failed, which is good. We don't want errors, we want failure, because we can easily correct failures. So let's go back to our vehicle, and now we've got to figure out what the distance is going to be. So let me x diff equals this x minus x, the difference, and int diff y equals this y minus y, so that's the difference between our y's. And let's see, what we want to do is get the square of those values. So let's do let's make a double here and say double sum of squares is going to be equal to x diff times x diff plus y diff times y diff. Whoop, I had diffy y. Y diff, okay. And I'm getting a compiler error because I'm not returning a value. And what we want to do is we want to return the square root of the x squared plus y squared. So now we've got to go to the math library. And here we have this is the nice part about NetBeans. You type a period in, and you get all the methods that are there in the class math. Next, and there's our square root. It takes a double as a parameter and returns a double. So I'm going to click on that. And That should get us close to where we want to be. I'm going to go back to vehicle test. I'm going to click run. I'm going to run, and all green, life is good. And so we've done test-driven development using JUnit. Very nice. So now, can you trust this code? Well, kind of, but there are still issues that we have. So for example, we tested negative world, but we didn't really test being in negative world. We only test not being in negative world. So here's what you can do. This is what I often do. I make a copy of the function. Okay, I'm going to get a compiler error because now I have two functions by the same name, but I just add a 2 here. Life is good. And let's make the x value negative. And now I'm going to run my code again. And I'm getting a failure. Expected false was true. Well, wait a minute. It's my test program that's incorrect. So this is another dimension of this. You've got to not only test your code, but you've got to make sure that your test program is operating correctly. So we're not expecting false, even when I copy that over. We're expecting true. So I simply change that, run my file, and now I have 4 tests that pass. Now, maybe the developer, maybe the programmer could handle a negative x but couldn't handle a negative y. So then I would take my test function, I would copy and paste it, I would call this 3, and let's make this a -10. We still should have test is in negative world. So with just a few keystrokes, I'm adding another test, I'm making my code more robust, I'm going to run it, and now all 5 tests pass. And it only takes a fraction of a second to actually run these tests. Okay, so this is what you want to do. You want to go back, constantly refactoring. Now I'm going to show you one more thing here in NetBeans about how you can add comments very easily. So I've got this method move by, and I'm going to move my cursor right above the method, and I'm going to hit /**, and then hit return. And what I now have is a Javadoc comment framework set up right here. So here I can write a sentence that describes what the function, what the method does. Moves the vehicle by x and y, and the parameter amount to move in x direction, amount to move in y direction. And now we have some nice Javadoc simply thrown into the program. And you should do this for all your functions, because then you can use the really nice Javadoc tool to produce automatic documentation for all your code. So to summarize how we work with JUnit testing, you write your test first, or basically at the same time, test what you think is going to break in your program, and then create new tests to show the bugs, then fix the bugs. So write the test, then make the code pass the test. That's the magic. Occasionally bugs will slip through, but what you want to do is when there's a bug in your code, write a test that will catch the bug, then fix the bug, and watch the bar go green. That's when life is good. So you are constantly improving your code. Your tests are there if you want to refactor to make your code more readable, make its performance improved. You can do so feeling confident that as you just run your tests, you're not breaking your code while improving it. That's the bottom line. So go forth and test. You go from red to green, refactor, red, green, repeat process until you feel good about your code and all is well, and you will not spend enormous amounts of time banging your head against the wall debugging your code. This is Dr. C. Go forth and test.